Welcome students. I'm going to talk to you a little bit about bearings today. We use bearings to describe the direction of one thing compared to another. So first thing to think about when you're giving a bearing is where you start from. So if this point here is our starting point, we'll call it A, and there's something over here, B, and we want to know the direction of B from A. We start at A, and we call north, or straight up, 0, 0, 0. What we then do is we draw a line to B. I'm just going to move B to here because I can't use this computer very well. Okay, and then we measure this angle here, and that would be the bearing. So I'm going to attempt to do that with this protractor here. I'll pick it up. Oh, nope, that's the page. How do I pick up the oh, here we go. Right. I'll spinny it round. Okay. And then I move my protractor to here. Okay, and I line it up nicely. Now, I'm dealing, this here is 0, so I'm dealing with this inner bit here. 0, 0, 0. I move around until I come to where this line meets, and I'm getting, it looks to me to be about, say, 121. So I would say that the bearing in this case is, come back here, 1, 2, 1. Okay, so if we were to do a rough diagram of this, 0, 0, 0, you know that this is 0, 9, 0, or 90 degrees. This is 180, and this is 270. And so you know roughly whereabouts a bearing is going to be based on where it is in this quadrant here. A key thing to remember, if you've got something in this range here that's less, or actually all the way up to 100, if it's a 2-digit number, you always put a 0 in front of it. So let's say you got one out here which is 45 degrees, you would write it's 045. Or if you got one that's 99 degrees out here, you'd write 099. So always give your bearings with 3 digits. Okay, I'm just going to clear all that nonsense. Okay, so that's kind of a rough introduction to how bearings work. I'm going to make some diagrams of some bearings. So the first one I'm going to do, oops, why is the eraser on? Okay, I'm going to do a bearing of 100 degrees. Okay, so I'm going to start off with a line. And maybe I will grab my pen for my ruler for that. Pick up my ruler. Okay. It's much easier doing this in real life, I can tell you. Okay. So I'm just going to rule a line. Let's see if this works. Come here. Okay. So that's my line. And then my next step, I'll pull that away. Oh, it's not quite straight, but you get the general idea. Remember, you're going to be more accurate. This is my starting point here, and I'm trying to draw a 100 degree angle from there. So I'm going to pick up my protractor. I'm going to, you can see this little line here. I'm going to line that up with the bottom here. I'm not quite straight on my line, am I? I might maybe spin it around a bit more. Actually, I'll just leave it. Make sure you draw your line straight. Okay, and then I'm going to go around to 100 degrees. Now, here's where some students get a little bit confused. Okay, where is 100 degrees? Oh, here it is. No, it's not. We're starting at 0, 0, 0, not at 180. So you're going to use these numbers on this part of the dial. So 100 degrees is about there. So I'm going to put a point there. Now you might have to put it here on yours because you don't have a computer like I do. Alright, now I'm going to pick up my protractor, get out of town, move it over here, grab my ruler, spinny spinny, and I'm going to line her up. Okay, this is not so good. That'll do. Okay, it's much easier when you're doing it in real life. Okay, and then I'm going to get my pen and I'm going to rule it. Okay, And I'm going to say that's my bearing of 100 degrees. Okay, well, let's say we had something that was a little bit different. Let's say we got something like 190 degree bearing. Okay, well, just remember, I'll draw this over here. Just remember that you know that 0, 100 is here. You know 90 degrees is here. You know 180 is here. So you know that roughly your bearing for this one is going to be like this. You're going to have a line, your straight line here, and then it's going to go out this way. And that whole angle there is going to be 190. So we're going to start again with the same line, even though it's a bit dodgy. We'll start with that same line again. And we'll get our protractor. Now, the protractor that I have only measures up to 180 degrees. Okay, so I know that 180 degrees is down this bottom bit here, right? But what I can do is I know that 180 plus 10 more on the other side will give me 190. So all I have to do is go out 10 degrees from here. So this 180 would be here. So I just go out 10 degrees, and 10 degrees is here. You can kind of see there's a 10 there. So this is my 10 degrees, right? Then I am going to pull my protractor away. I'm going to grab my ruler and try this debacle again. Oh, seriously. And they say technology is progress, eh? Alright. I'm not very competent at using this jolly thing. Okay, but you get the general idea. You can be a lot more neat with yours. Okay. So then we get our pen, draw our line, and that is essentially a 190 degree bearing. 190 degrees. What if we wanted to do a bearing of, say, 290 degrees? Okay, well, let's go back to our wee diagram over here again on the right hand side of our page. We know that this is come back here, pen. We know that this is 270 here. So we know that 290 is going to be up here somewhere. Okay? And you know that the whole way around is 360. So you can go, oh, if I just measure this little angle here, that should be 70 degrees. So let's get the rubber and try and draw a 290. Okay. So I'm going to grab my protractor again. And I know that I need to measure back 70 degrees from 360. So this would be 360 here. So measure back 70 degrees. 10, 20, 30, 40, 50, 60, 70. So this is where 290 degrees would be. Again, grab this, and I'm not going to grab the ruler this time. I'm just going to do it freehand, which could be, ooh, don't know why that moved. Okay, and I'm just going to join this up. Okay, so that angle there should be 290 degrees. So this is how you draw bearings. The second thing that we need to be able to do is construct scale diagrams. So let's say I needed to do one like, let's say I had to do, somebody travelled 100 kilometres on a bearing of 040. Now, when you've got to draw a scale diagram, you've got to first of all decide on your scale. Now, I'm going to use a scale of 1 centimetre on my page is equal to 10 kilometres. because if I made my scale 1 centimeter is 1 kilometer, I would need to have a 100 centimeter page. Now, you don't have a page that is that big. That's a meter, remember? So you've got to think of a scale that's going to work. Now, what I'm going to do next is I'm going to get my ruler and spinny. I think that's kind of good. And I'm going to draw my line in. This is going to be my north line. Get my pen. It's not quite right, is it? But you get the general idea. Okay. Oh, what am I doing? Hope no one's getting motion sickness there. Okay. So we would say this here is our line 0, 0, 0. And we're going to say that this is our starting point, this little bit here, at the crosshairs there. Okay. So hopefully that's our starting point. Now, the bearing is 40 degrees. So now I'm going to get my compass, my protractor, pick up that, and I need to make a bearing of 40 degrees, 40. So I line up this little line with the crosshair there, like so, and then I'm measuring 40 degrees. So I get my pen, I'm measuring the inner lines here, not these outer lines, because I'm starting at 0, 0, 0, so 10, 20, 30, 40, so it's here. You can see that 40 there, okay. All right. Pull that away. There we go. Get rid of that. Now, so that's the bearing. It heads off in that direction, but how far in that direction does it head off? 100 kilometers. Now, what is 100 kilometers in centimeters if this is my scale? Well, I'm just going to write over here, I need 100 kilometers. How did I get from 10 to 100? I times by 10, so I need 10 centimeters. Okay, so this, I've got to go 10 centimeters on this bearing. So I'm lining that up real carefully. Swing it around slightly. Okay, I can see that my 10 centimeter, I hope you can see it, is over here. Right, so I need to go that far. So I'm just gonna very carefully rule my line until I get to 10 centimeters. That looks to be it about now. Okay, so that's my scale diagram. And sometimes you'll be asked something like this. Okay, where's my pen? How far east and north did it travel? Okay, now you know it started at this point here, and you know it's gone across all the way to about here. Okay, I could get my ruler and go straight down. It's gone that far. So if I measure this along this little red line at the bottom here, if I measure how far that is in centimeters, I can find the east distance. And I measure this red line up to here, I will get the north distance in centimeters. And then I can convert it using my scale diagram. So that's what I'm going to do next. Just going to shorten this, it's getting a bit unwieldy. Okay, so I'm going to line this up here, and it looks to me that the height of this is 7.5 centimeters. So I know that I've traveled 7.5 centimeters north. Now I've got to convert that using this scale here. If I've got 7.5 centimeters, I've got to times it by 10 to get my kilometers. So that's going to be 75 kilometers north of its original position. And I'm going to work on my easterly direction. Now that looks to me to be approximately 6.5 centimeters. So I'm going to write 6.5 centimeters east, and then using my scale I'm going to multiply it by 10 because of the scale I used, and it's going to be 65 kilometers east. Okay, now that's generally what you do with scale diagrams. I think I've got a few of those for you to do. I think number 10, you're doing a couple from number 10, so that's how you do them. You're going to need to get the ruler out, you're going to need to get your protractor out to do these, and this kind of thing will be in the test, so watch very carefully what I've done and copy it. Sometimes you might use a different scale, like you might use a scale of 1 centimeter to say 5 kilometers, or if it's a small number of kilometers that something's traveled, you might go 1 centimeter equals 1 kilometer. For example, if you've only traveled 10 kilometers, that might be a better scale. So think carefully about that. The only other thing that I really want to talk to you about is the relationship between some bearings. So let's say, I'm just going to do a really rough diagram here to give you an idea. Let's say we've got something like this. This is point A, and this is point B. Now, let's say that, I don't know what this is, I'm not going to measure it, but just say I've measured it, and let's say it was 140 degrees. Okay? So we would say that the bearing of B from A is 140 degrees. Okay? The word from is important. That's where you start. So wherever it says from something, you start measuring from there, okay? Now, what about if we were doing it the other way? How would we find this? The bearing of A from B is. How do I find that? How can I figure it out? Well, remember, you start at 0, 0, 0, and you must always measure clockwise. Always measuring clockwise. So hopefully you can see that this bearing is going to be greater than 180, and it's going to be greater than 270. So 180 would be straight down, 270 would be the westerly direction, and it's greater than those. So how do we figure this out? Well, I'm going to show you a little trick. You could, of course, measure this angle here and subtract it from 360, okay? But if you already know a bearing, like this one here, you should be able to work out the rest. And let me show you why. This angle should be 40 degrees, if the other one is 140, because these are co-interior angles. You've got two parallel lines, and if you've got two parallel lines, the angles these two angles between them, this one and this one, have to add to 180. Okay? So we call it co-interior angles, add to 180. And then if you know that this is 40 here, you know that this whole angle here must be 360 take away 40, because angles around the point add to 360. So 360 take away 40 should be 320. So the bearing of A from B is 320. Let me do another example with you, just to consolidate. Let's say, for instance, that we have something like this. So that's 0, 0, 0, that's your north line, and this is 0, 0, 0. Let's say that this is B, and this is A. And let's say the bearing of A from B is, let's say, 045. Let's say, for example. What that means, remember, we quickly look at the from. that means that's where we're starting. So we're starting here from B. So that means that we've got this here as 0, 4, 5. Now, let's say I wanted to know the bearing of B from A. Well, that means I'm going to start measuring from A, and I'm going to go clockwise, starting from the north line until I meet this bit here. Now, I could measure it, or I could work it out. I can first of all figure this out, because 45 plus this must add to 180 because they are co-interior. So this should be 135 degrees. And if this is 135 degrees, this whole thing here is going to be 360 minus 135, and that gives us 225 degrees. So it'll be 225 degrees. Okay, this is getting a bit long. I suggest if you're having trouble with this, you watch this video a couple of times. I think this contains all of the main points that you need to do the exercise, but by all means, if you are struggling, please let me know. All right, take care.